Hi, today's lesson's on inverse relations and functions. So what is the inverse representation of this? What an inverse is if I plugged in x, in a normal function, I plug in x, I get y. That's what this table shows. The inverse is I plug in y and I get x. So how do we represent that with a new table? Well, we say x and y, and all we do is flip them. So this becomes 1, -2, 4, -1, 3, 0, 1, 1. So in other words, this says if I input 1, I get -2. It's the opposite of this, or the inverse. The backwards of it, if you will. So how can we do this algebraically? Well, if we know squared, let's just make a quick table so I can show you. If it was 1, 2, and 3, if you square those, you get 1, 4, and 9. So the inverse would be 1, 1, 4, 2, and 9, 3. And that should look familiar. This is x squared. If I square these numbers, I get these numbers. But what do I do to these numbers to get these? Well, you should notice it's a square root. So basically, what cancels that out is what our inverse is. And so that's basically what we're going to do. So if we look at this, how are the graphs of these related? Okay. So if you look at the graphs, I'm just going to do a quick sketch. X squared looks like this. We know that. And we know the square root is like a swoop thing that looks like this. But if we do the negative, it'll be flipped underneath. If you notice, these two u's are symmetrical, but across a very specific line, which goes like this. And that line is called y = x. That is something that's covered in geometry. And basically, these are reflections across a line. You can imagine them folding on each other. And so that's basically how you can see if something's inverse. And by the way, they should share some points across that line. Maybe. Go ahead and try this problem. So, how do we do this? Well, we have two steps. To find the inverse, all we have to do is two things, is rewrite, actually more than two things, rewrite f of x as y equals, switch x and y, solve for y, and then rewrite y equals as f to the -1 of x. -1 is shorthand to say that's the inverse of f of x. So let's go through my steps. So y equals x minus 2, switch x and y. Now solve. So we're going to square. So x squared equals y minus 2, add 2, plus 2 equals y. And now we're done. Now we're going to rewrite y equals as f to the -1. So -1 of x equals x squared plus 2. And that's it. Try this problem. Okay, to find the equation of an inverse function, okay, let's do it again. So y equals negative cube root of 4x, switch x and y. Now I'm going to move the negative over, so negative x. I'm going to cube both sides. So cube over negative is just negative. Divide by 4. I'm going to write it as a fraction, just because it looks cleaner. And now we just rewrite. So f to the -1 of x equals -1/4 x cubed. Go ahead and try this problem. Now, we can use composition to verify inverses. What happens is, in general, to know that it works, is you're going to have f of g of x equals 1, or g of f of x equals 1. Actually, they both should. Just use one of them. If one of them works, the other one most likely will work. So, what is the inverse of this, and how can we verify this? We could use the graph too, but we're going to use this. So, first of all, I'm going to rewrite this as f to the negative 1 of x equals x minus 5 over 2. That's what the inverse of it is. There's a shortcut to do it, but you have to ask me directly. So, this right here is, now we're just going to plug it in. So we're going to do f to the negative 1 of x. So wherever f is, we go 2, like that. Put this inside, because that's the inverse. And we get the 2's cancel. So x minus 5 plus 5, which equals x. So that one checks out. Let's do it the other way. So same story, we're going to do parenthesis minus 5 over 2, but we're going to plug in 2x plus 5. So we get 2x over 2, which is x, so it checks. So there's how you verify it, that you did it correctly. So because of that, we can answer the question if two things are actually inverses or not. And the same thing, we do exactly what we just did. So I'm going to do f. Yeah, f of f to the negative 1 of x. So f of x is parenthesis squared plus 5. Then we're going to plug in square root of x minus 5. Now, if you notice, this is not going to go. There is no way. But just to show you, you get x minus 10 square root of x plus 25 plus 5. That is not going to clean up to x. Nothing's canceling, nothing. So this is no. They are not inverses. Go ahead and try this one.